Download this code and get free GPT-4o from codegive.com, link in the description below. Depth first search, DFS, is an algorithm for traversing or searching tree or graph data structures. The algorithm starts at the root, or an arbitrary node in the case of a graph, and explores as far as possible along each branch before backtracking. DFS can be implemented using recursion or an explicit stack. In this tutorial, we will focus on the stack-based iterative implementation of DFS in Java. Key concepts of DFS. 1. Graph representation. Graphs can be represented using an adjacency list or an adjacency matrix. For this example, we'll use an adjacency list. 2. Stack data structure. We'll use a stack to keep track of the nodes that need to be explored. 3. Visited nodes. We need to keep track of visited nodes to avoid cycles and repeated visits. DFS algorithm steps. 1. Initialize a stack and push the starting node onto it. 2. Create a set, or Boolean array, to keep track of visited nodes. 3. While the stack is not empty, pop the top node from the stack. If the node has not been visited, mark it as visited. Process the node, example print its value. Push all its unvisited neighbors onto the stack. Java code example. Here's a simple Java implementation of DFS using a stack for a graph represented as an adjacency list. Explanation of the code. 1. Graph representation. The graph is represented as a list of lists, where each index corresponds to a node and contains a list of its neighbors. 2. DFS method. The depth first search method performs the DFS. A stack is initialized, and the starting node is pushed onto it. A while loop continues until the stack is empty. Nodes are popped from the stack, and if they haven't been visited, they are processed, printed in this case. Unvisited neighbors of the current node are pushed onto the stack. 3. Main method. The main method sets up the graph and initiates the DFS from node 0. Conclusion. This tutorial provided an overview of the depth first search algorithm using a stack in Java. This iterative method is efficient for traversing graphs and trees, especially when the graph is large and recursion depth might lead to stack overflow. You can modify the depth first search method to perform different operations when processing each node, such as collecting data or building a path.